Hi, welcome. It's Jim from the maverickstar Observatory. Guys, we talk a lot about the planet Earth and the anomalies that are taking place with the Earth, like the magnetic reversal, how the Earth is being affected by the grand solar minimum, and, the earthquakes, the volcanic activity, the magnetosphere that protects us from the harmful cosmic radiation. But, there was, at another point in time, a planet in our solar system, our neighbouring planet Mars, which probably had very similar occurrences that set it in motion to look as it does today. That's what we're going to get into today. So before we do, as usual, big thanks to those of you that are supporting us, guys. We're nearly at the end of January, and I've been saying for the last 3 months that this is the worst time for raising funds for our channel, our observatory, and all the work that we do. So if we can raise a little bit more money towards the end of the month, we've only got a few days left, we can try and make a difference. It's as simple as that. So let's begin. We're talking about Mars. NASA at the moment have got a project called MAVIN, and the idea of this project is to send space satellites to Mars to study its magnetic composition, and as well as that of Venus. What they're trying to do is understand how their environments on these two planets has ended up the way it is. We know when we're looking at Mars, we seem to know a lot more about Mars than what we do about Venus, and that is simply because Venus has such a dense gas cloud around it that it's hard to see the surface. Although recent spacecrafts have visited the poles on Venus and found that there is an atmosphere high up in the altitude, which they believe could support life. So if it is high up in the atmosphere, it's got to be a bacterial life that maybe be able to survive, because down on the surface, it's believed the conditions are way too off the chart to sustain life because of the composition. But more interestingly, Mars had on its surface water, and we know how important water is for life on Earth. Without water, we simply don't have any biodiversity that is, as we class it, alive today on this planet. So it did have water. One of the other things it had, which not a lot of people know about, is it had a magnetosphere, and it was probably the result of it losing its magnetosphere, because it no longer has it now, and they found this out in the last 30 odd years or so, when they flew a spacecraft over Mars. It was scanning the terrain for magnetic anomalies, and it had scanned a recent impact crater which removed the most recent dust from the surface of the planet, and that enabled the magnetite that had set in the rocks from the last magnetic reversal, or magnetic or magnetosphere, or something that was going on in the core similar to Earth's, that was generating a magnetosphere. It had set it as it does do on our own planet, and the spacecraft had detected it. And when they discovered this, obviously it was big news, because they knew that at some point in the history of Mars it had a magnetosphere. Now, it's important because we know that now, studying magnetospheres, we know how important they are. They are equally important to life on a planet as water is, because there are certain things that a planet needs in order for it to sustain life. The first one is water. It has to be liquid water, and we know at some point on Mars's surface it had liquid water, because if we look at the terraform, we can see those little riverbeds that would have took thousands of years to form, with flowing water going through them to erode those river canals that we see that look like little veins on the surface of Mars. But it also had a magnetosphere, which probably protected, first of all, its atmosphere, and then secondly, its water. And why is this important to study planets like Mars and then compare it to our own? It's important because our planet used to go through a magnetic reversal on average every 350,000 years or thereabouts, and recently we are going through a magnetic reversal. But the big difference is that we are 500,000 years overdue the full reversal. That means, or could mean, let me say, that something has changed in the core of our planet, and that in turn has changed the way the magneto works, and also that affects the way the poles behave on our planets, and the magnetosphere, which protects us from that harmful cosmic radiation. Because if we lose our magnetosphere, and it's not uncertain whether that will be the case because of the longer period of time in which it's took to reverse this time, if we lose it, we could end up looking like our neighbouring planet Mars as a result. And that's why, you know, this topic has really captured my attention, and I feel it really is important to cover it like we do at the Maverickstar Observatory, and you know, relate to you guys out there now, which are as of from the other day now 30,000 strong. So we are slowly getting the awareness out, and we're talking about the importance of these things that protect our life, protect our planet's water and atmosphere. Because when we lose the magnetosphere, our upper atmosphere is subject to a term NASA described as sputtering. If you go onto Poleshift News, our host website, you'll see in the Learning Centre a video, you know, just talking about, you know, sputtering. It's also, I think it's been produced by NASA with regards to the MAVEN mission, which is now studying these two Venus and Mars planets. So, you know, if we lose our magnetosphere, you know, we stand to lose our upper atmospheric protection via sputtering, which is iron stripping away our upper atmosphere, knocking other molecules out into space, and eventually we lose the atmosphere. And then in turn, you know, the waters on our planet would be subject to evaporation, and then further sputtering, and probably remove the waters off the planet as well. And we would end up looking very close to how Mars does today. So, you know, I wanted to talk to you guys today about Mars and how it used to look many thousands of years ago, but tens of thousands of years ago, and just bring back home, you know, something similar which is taking place on our own planet today. And, you know, it did take place on another planet. So, you know, suggesting that, you know, if we lost our magnetosphere this time round because of a prolonged reversal, it seems like something has stalled or slowed down definitely in our core on Earth. You know, we could end up going through, you know, a course of actions that would enable our planet to then look like our neighbouring planet does, Mars. But could you imagine if that was the case, guys? That would mean life on Earth could cease to exist, and this is a real possibility. This isn't science fiction. You know, Mars did have water, Mars did have a magnetosphere, and, you know, it no longer does. And it very likely, although we haven't found it yet on Mars, it might have had life, even in its simplest of forms. It might have had it. It still might have life now, but we just haven't found it. And the life that we're looking for is probably not like what we would expect. I mean, it'd be great if we did find, you know, multicellular organisms like little rodents or something still alive on Mars. But I think, you know, we would be equally excited if we just found, you know, something that managed to stay alive in a bacterial size manner. So, you know, I just thought I'd bring that to your attention, guys. You know, the magnetic reversal isn't something that we should just completely overlook. In fact, not many people are even aware that our Earth is going through a reversal at this point in time. And they're even not aware of when the Earth went through a last magnetic reversal. They don't know how important the magnetosphere is to the survival of ourselves on this planet. And without it, we stand very little chance of keeping those, you know, those important things that we rely on to keep and sustain life on our planet. So, you know, it is important to, you know, look beyond our own planet at the history of other planets and study those and then we can gain a little bit more information as to, you know, what we could be letting ourselves in for, because our planet really could, in years to come, end up looking like Mars. And if that was the case, it would be a terrible loss, you know, to, I believe, this universe, because planets like ours are so rare. You know, to get a planet that has liquid water, and it needs to be in a liquid form, because if it's a little bit further away from our sun, you know, it's frozen. If it's too close to our sun, then it's in only gaseous form. So to get it in the Goldilocks range, where it's just right, is really, really critical, and we're lucky to have it. It's a rare planet, ours is. We haven't yet discovered a planet that we can reach with those important things on it. So, you know, if we was to go looking for planets that we could live on, you know, one of the things that we would want to first of all know that it had got before we travelled to it would be that it has water, and secondly, we would want it to have a good magnetic field that protects it from the environment of the space with regards to cosmic radiation. And this is why it's important, guys. At the moment, you've seen the charts that I've provided. We have a lot more cosmic radiation inbound as a result of two things: the grand solar minimum, reducing the heliosphere, more cosmic radiation, and a weakening magnetosphere, again allowing more cosmic radiation in. So our first and our primary protection is weakened right now. And you know, if we look back at the last solar cycle 24, we could see that even at the solar cycle maximum in that cycle 24, it wasn't enough to protect us like all the other cycles that we've experienced. We could be really witnessing the beginnings of something very, very ugly happening on our planet. And it's very easy for us all to just go about our business, because, you know, first and foremost, we have to look after ourselves and our family, and then friends, and then community. But you know what, guys? We also have to look a little bit further afield and protect our planet as best we can and understand its mechanics. So I'm going to leave it here, guys. I'm just going to mention that there is a link down there, and it'd be great if we could beef up a little bit of support before the end of the month, or the month ends. And if you want to do that, you want to join us, because as you know, we don't just talk about these things, we build equipment, and we've got 4 magnetometers to build over the next couple of days, and finish off a couple of muon detectors, and I'll do a couple of videos of the build of those components coming together, and then it's a matter of getting them out, and that's going to be exciting. I'm really looking forward to getting one in Brazil and one over in the south coast of Australia, to figure out what sort of protection we get from strong intensities of magnetic protection as opposed to the weak. So guys, the link's there. Enjoy your day, and I'll catch up with you at some point in the week. Okay, as always, bye for now.